So picture, put it right in there. Boom. Okay. It's your fish. Okay. Rich Brown. I'll be Rich Brown here. Okay. Good morning, good afternoon. My name is Richard Brown, Director of Marketing for Electroscan Incorporated. Electroscan started in 2011, doing all these products for water and sewer to find leaks. But we got a special one called Swordfish, and that's what I'm going to talk to you about. It's based on all of our other products, and we answer the question, what is electrical resistance testing? Well, it's not acoustic. So one of our competitors thought you could listen for lead pipe. They withdrew from the market, and so now there are only two options to locate lead pipes. You can either expose the pipe through potholing, also called daylighting, also called hydro excavation. Mm-hmm. And then once you expose the pipe, you do a little magnet test. Scratch the surface, see if it's, but you got to do the whole pipe. So the question really is to dig or not to dig. The other problem with potholing, when you're digging the pipe, is it causes vibration in the pipe. What do we mean by that? Well, inside pipe there could be debris, biofilms, calcification, just when the pipe gets older, galvanized pipes. So when you're potholing and you got 3, 4, 5,000 pounds per square inch PSI on that, knocks all that stuff loose, goes directly in a person's tap water. You don't want that. And we know just by taking little video cameras, and we know that there's movement inside of the pipe when you pothole. We've always done flushing of the pipe afterwards. Mm-hmm. This is the AWWA standard. Standard is C810-17. 17 means that it was passed 2017. And we brought to the market Swordfish, the total solution. Not just the base unit, but the probes, a laptop or a cell phone, Wi-Fi, lead tests, I'll get to that in a second, insertion tubes, grounding stakes, web-based reporting, all part of the package. And what is that electrical resistance? It's what you learned when you were in 4th grade, when you put 2 wires in water and saw it connect to each other. Just like the periodic table. And the key line is this line number 3. Look at the difference between copper, that's Cu, and lead, Pb, is electrical resistivity. Look how different those numbers are. Every element in the periodic table has its own electrical resistance. That's what we measure. AWWA has seen this. We've always been in the M77 directory. And how it works is by putting the probe in, we can use electrical resistance testing to see the different pipe materials. We measure the change in resistance. So as we go from one pipe to the next, we can tell automatically. No interpretation. And as we're going through, all of the data pops up into the Amazon cloud. We process that in critical H2O, and out comes a report less than 5 minutes before we leave the customer's site. So whether they have no lead, we document it. Or whether they have lead in the pipes, we document that too. So how do we get here? What is the Electroscan story? Well, I told you we had these other products, but we really saw some early hurdles. How do we get into a pressurized pipe that's so small? How do we make sure the device is clean through a chlorination chamber? And that's exactly what we worked on. We created a chlorination chamber that we can go and enter under pressure up to 150 PSI. Here we're showing a pipe 90 PSI that we're going into. On the right-hand side, we're in a basement, going against pressure from the basement all the way out to the water main. So we have a chlorination chamber. where our cable goes directly through and is cleaned before it enters the pipe. We also have a distance encoder to see how many feet we are in the pipe. So the hurdle that we had to deal with next is how do we navigate through a pipe? And look at through a typical meter setting, we have 180 plus 90 plus, that's 360 degrees of turns that we have to navigate. Whether we enter through the basement or we're entering at a curbside. And what we did over the last 4 years is evolved what our probes actually look like. See this middle probe? We were going around corners. We were overcoming joints. We call that our Lego probe. In some cases, we still use that today. Why? Well, because we want to get through those pipes, and at sometimes we have a single pipe. This is what copper looks like. High resistance, very high on our scale. It's different than plastic, very low resistance, very low on the scale. You can see it right away. Galvanized, kind of right in the middle there. We see what that is. But what we see a lot of is this. Why is this important? And what do these dots mean? Every dot is a reading taken at 1/3 of a second. Lead's kind of inconsistent, kind of jumps around a bit. You wouldn't want to EKG it to look like this, but here it is. We can tell that. But we also get 2 pipe materials. Here we are in a galvanized. Look at each individual dot here. It changes up to a copper pipe. Here we have galvanized that goes into a lead pipe. So we've got over 100 different meter settings that we've gone through and practiced with. And your community may be a little different. And if we take a look at a cutaway of one of these meter settings, we can tell in some cases we may hit a wall and it doesn't easily go in. So we've actually created different insertion tubes to help us with that. Here's a standard. Here's a number of basement meters we've had to go through. And it's almost like the Wheel of Fortune. How many different kinds of meters? Is it lead with protective coating? Is it unknown? Is it a non-lead pipe? Is it 100% copper? Is it 100% lead? Is it galvanized requiring replacement, or is it galvanized going into copper? This is what Electroscan does. A couple of quick studies I'll just run through. First of all, in Baltimore, we're doing 10,000 homes in Baltimore. We do everything from door hangers to service lines, reporting, flushing the line, all within about a 30-minute time. And if the worst happens, we've got to leave them a filtered water pitcher, we do that. We're canvassing all 14 city councils, leaving a 30-day notice and a 2-day notice as we go. Second case, Rock Hill, South Carolina. One of our first users, a do-it-yourself case. They purchased a swordfish. They're doing that themselves. Featured in Trenchless Technology magazine. Our third case study, Town of Medley. Look at this population, 1,036. Interesting thing about this, a lot of warehousing. At the top, at a normal day, there's 60,000 people that work here. Our first trailer park coming in, 0 lead. We were done with this project within 2 weeks with the help of our partner, Element 82. This was interesting at California Elementary School, which I won't name. They've been trucking in bottled water for the last almost 10 years. 33 inspections, 15 were lead. And these were mostly lead fixtures. Identified them all. Last case study is Bard College. And what I want you to notice is this footage encoder here. 50 feet, we actually went in 50 feet. Normally you can do 3 to 10 feet, 20 feet. Our cable goes up to 80 feet. A lot of famous alumni. This is right up the Hudson River, right off the Hudson River. Again, with our partner, Element 82. We do lead testing after we test it. Why is that? Well, if we go into a pipe that's galvanized, for example, we want to see if there's any trace of lead. If there is, it's going to turn red, and we know that's going to be a galvanized pipe requiring replacement. It's very easy to do. So we do a test. It's like belt, suspenders, and duct tape to hold your pants up. And if there is, we leave a lead filtered pitcher. Got a great strong partnership with our good partners, Emmy Simpson out of Valparaiso, Indiana. And we also have a new relationship with Crown, a NASDAQ listed company that has element 82 and PE pipelines that does a 360-degree identification and remediation. They have the ability to use a multitude of trenchless methods to replace the lead pipe. Well, that's all I have today. My 10 minutes are up. Got any questions, or I'm here to answer them. If not, send me an email. richbrown@electroscan.com, or text me, because I'm up all hours of the night. That's all, folks. How long did it take?
Man, that was 11 minutes.
Oh!